if we need to change our configuration, there are two areas that we mostly need to look at. Well, three. Let's start with the most basic thing, and that is how the phone connects to the microcontroller. As a default, we are now assuming Bluetooth, but if you don't want to use Bluetooth and it's coming up here on your first run and complaining that it's not finding a Bluetooth to connect to, then the place you need to go is in here to phone configuration. And here, this is probably easier to see this, but that's harder to read. Okay, we'll stick with this. You can scroll this. One of the things you can change is how low you want to let the battery go before the thing goes into sleep mode to protect itself. We have it set at a minimum of 10, but you can make it higher if you want. And then, depending upon what you're doing, you might prefer to use one of the USB modes. This is where you do that. Okay. Currently, the app storage on phone versus app storage on EEPROM is grayed out because we're only storing it on the phone, but we will soon be enabling EEPROM storage, and then the storage on the phone will become just a backup and a quick access point when nothing has changed. And then the other thing you can change here is tell the system which way the phone is mounted on your robot, because sometimes people will have the display facing the rear of the robot and they're using the rear facing camera, which typically has higher resolution capabilities, as their camera to view where the robot is going, or they've got it the other way and the device faces the front. In any case, you need to be able excuse me, I forgot about my cough button there for a second. You need to be able to tell it which camera you want it to use. We don't make any assumptions in here based on which way you've configured the device to be facing. We don't assume we can diagnose which camera should be used, because the camera naming across various brands and types of devices varies a lot, and they don't always make it clear which camera is facing which direction. So you can go in here, and what you're seeing here is basically the camera index as we get it in a list when we query the device's system. And if the camera object has an indicator for whether it's back facing or front facing, then we also display that here. You won't always get that. So you pick which camera you want, and then you tell it when you're done, and it saves your changes and returns you back to whatever mode you were in previously. By the way, on the Android device, you've got a hardware, or at least a system, back button and a menu button, and other buttons as well. But our app does pay attention to those first two now. So if you hit the back button when you're in one of the configuration screens, it'll just come back to the previous screen without saving any changes. If you have no other screens to go back to, then it will ask you if you were trying to exit the program and let you say yes or no. The other button is that we pay attention to is the menu button, and when you touch that, it'll toggle on and off the action bar tray just like that. Okay, so when you want to configure something other than the phone, or in the case of when you're in client-server mode, the server connection settings, then you need to be in developer mode. So first thing we want to do is switch to developer mode, and then bring up this menu of configuration options, and now you can see those bottom two buttons are now enabled. And so the first thing we want to look at here is the robot capabilities configuration. So we bring that up. It takes it a little bit to load because there's a lot to load. And it tells you which schema version it's using, and then you can scroll through many different options that may or may not apply on your particular robot. So, for example, if your robot is capable of doing waypoint navigation, you're going to want to turn this on. And depending upon how you're writing your code, we have 3 different ways we can send you GPS coordinates. This applies to sending whatever the current coordinates are, and also the coordinates associated with a waypoint that the user has triggered on the control panel. So depending upon how much accuracy you need and what you want to do with the math, the default is to send Arduino floats, which are 4-byte, correct, 32-bit floating point numbers. They don't give you very good accuracy on GPS, but they are the native floating point number for most Arduino systems. If your Arduino or your microcontroller, or to be a little more general, can handle 64-bit floats, true doubles in other words, then you would, and you want that mode, then you would turn off the floats as 32-bit and you will get the full doubles. But most Arduinos can't handle that. And then if you want to go with integers, you turn off coordinates as floats entirely. And then you can also set what is the most rapid rate at which you want to get updates for the heading and the current GPS location. And these are both defaulting to 5 seconds. If you get them too frequently, it can just overwhelm your processor. You've got so much going on there because you've got other things going on besides the waypoint navigation, and getting these updates too frequently can really bog things down. So we give you control over how frequently you want those. Okay, and then I see sometimes my grouping of these things doesn't work quite right. This pan enabled should be underneath camera pan properties. Please forgive me. Okay, so if you have a robot that can move its camera around, either by moving a lens or a prism or a mirror or something, or by actually moving the whole phone on a turret, then you can turn these things on: pan enabled and, if appropriate, tilt enabled. And then further, if your robot achieves panning by moving the whole phone around, you want pan moves device to be on. If it leaves the phone alone and just moves a mirror or something, then turn that off. The reason for having a setting for that is that when we're using the phone as our sensor package to determine the orientation to determine the orientation of the robot in 3D space. So if you use the phone, you move the phone around to aim your camera, then we need to use inverse kinematics to back that change out of what we're sending to the control panel about what position the robot is in. So you have the same thing on tilt. If tilt is accomplished by moving the whole phone around, then you're going to want that, you're going to want that to be on. If it's by moving a mirror or something else that doesn't affect the position of the phone, then you want that off. Various other things, if you have a shaft encoder for reporting speed, these things apply. Ultrasonic Ranger, if you want to report any of that. If you just want to handle it locally and do emergency stops based on the fact that you're about to run into something and you don't want to report it upstream, that's fine, you don't have to. But if you want it to be displayed on the control panel, then you can turn this on. And then this basically says whether you're going to be reporting temperature. It gives you two options for battery levels, for a clean battery, dirty battery sort of scenario. Give a maximum speed so that we have a way to set an appropriate range on the gauge on the control panel. And then if you have a headlamp or some sort of light on the robot that you want to be able to turn on and off, you can turn that on here. And then finally, where we talked before about setting up which way the phone is mounted on the robot, this is where you tell it about that. If the display side of the phone faces the back of the robot, then you turn this one on. If not, then you turn it off.